Hello everyone, today I'm going to solve this Leetcode problem 410, split array largest sum. The problem is given an array nums, which consists of non-negative integers and integer m. You can split the array into m non-empty continuous subarrays. Write an algorithm to minimize the largest sum among these m subarrays. So typically, the problem is given, for example, this nums array with a few different integers, and then it's given a number m. That means the subarray in this for this original array is 2, and for this case, it can have different ways to partition the original array. And then for this specific way, so we put the partition in between 5 and 10, that gives us 18 as the largest sum among these two subarrays. So 18 is the smallest such largest sum comparing with other ways of partitioning. Okay, so for this problem, we are going to solve it with a very smart way, which is a binary search to guess the result. So for guessing, we are going to have a range of integers to guess the result from. So first of all, we need to calculate two things. One is max, which is the max value in the original array. In this case, it is 10 because if we want to have n number of different subarrays, 10 as a single integer, it will be itself a subarray, and its value is the largest among all the individual integers here. So the largest sum among those subarrays will be 10. So that will be the lower bound of our search range. And then the sum would be the sums of all those numbers. If we only have one subarray, which is itself, so the subarray, the sum, the largest sum of that subarray is the sum of all those integers. Okay, so we want to find the result, which is the largest sum among these subarrays, and then find the minimized one. So here we need to actually write down a help function. Here we call it binary search. We have some parameters, and we have our high and low to put here. Let's put high first and low after it. So what is so we are going to define this help function here. It's global, so we put self here. We also need nums and m as the parameters. We also need high, which is an integer. Low is also an integer. So the return type, we are going to have integer. Okay. So since we already have high and low, so we are going to write down the binary search template for solving this problem. I like the template which is smaller than equal to high. So for this one, we are going to calculate the mid, which is the low plus high divided by 2, which is a quotient, and we are going to check if this, so this one will always be our guess. So if the guess is valid or not, if it is valid, so here we actually need another help function. So if it is valid, that means our guess is larger or equal than m. No, larger or equals to than the largest sum. And we also have m different subarrays. Yeah. So if that is the case, that means we need to find the minimum answer from a lower number range. So that means we need to meet -1. Okay, else we need to find from a left-hand side, which is +1. Okay, this one I need to put it as low. Okay, low. Okay, high. Okay. And then after the binary search, I'm going to return the low, which would be our result. Okay, now we have to work on the help function here. So let's do this first. So this would be a global function. We are going to put in nums, m, and a guess. Okay. So it's valid. We need all those parameters here. And another one, let's call it the subarray sum. Okay. Our return type would be a bool, true or false. Okay. So for this one, like what we wrote here, I'm going to put it here. So subarray will be always our guess. If we are going to make sure it is larger than the largest sum with this m number of partition subarrays. Okay, so for doing this, we need a couple of variables. In this case, we initialize counts equals to 1. That is the number of subarrays, and we are going to have this. Let's call it current sum equals to 0. So I will have this for loop to traversing the integers in the array. For each one traversed, I'm going to add it to the current sum. And then we check if current sum is larger than our guess. If it is larger than our guess, that means we could not have that current sum combination, so we need to update it to okay. And then count also need to add 1 because we have one more subarrays. And then we do another check, which is if the count larger than m, we are going to return false because that is not a valid guess. we have more than m number of subarrays. If it is if after the traversing we didn't got any false, we are going to return true, which means we got m different subarrays with the guess, which is larger than the larger or equal to the subarrays larger than sum. Okay, so let's do time complexity. In this case, would be n times log s, where s would be our search range, which is in this case minus the underscore sum minus max. Since for each binary search we have this valid check where we do we have this for loop which is n time complex. Space would be O1. Okay, let's check if binary search is not okay. That's easy to fix because it is a global function. Let's submit. Okay, 35.99%. Thank you for watching.